Hello everyone, welcome back to my channel. Today let us discuss laws of electrostatics and magnetism in using the vector calculus. So let us try to express the Gauss law of electrostatics and magnetism using the vector calculus. So let us remind ourselves what is Gauss law for electric field is. So Gauss law for electric field tells us that the amount of flux passing through a closed surface is proportional to the charge enclosed in the closed volume. So let's consider a closed surface like this. So I have considered here a cube. You can consider any image, any closed surface like sphere or cuboid or anything like that, and consider the amount of electric flux emerging out of this object, the closed surface. Now the electric flux can be E bar or the flux density vector D bar you can take. So you are taking here electric flux density vector D bar, which is nothing but it's equal to epsilon times E bar, where E bar is the electric field vector and epsilon is the permittivity of the medium. So therefore Gauss law of electrostatics can be written mathematically like this. So it is the closed surface integral of d bar dot ds bar. So all over this closed surface we have to find out what is the flux coming out and add it over all the surface. So that means surface integral, closed surface integral of d bar dot ds bar is equal to the charge enclosed by the closed surface. So let's say within this surface we have the charge, total charge enclosed is q. So charge enclosed by the surface is q, therefore this integral is equal to q. So this is called as the mathematical form of the Gauss law of electrostatics. Now let us see how we can rewrite this equation using the vector calculus. So in vector calculus we studied divergence theorem, Gauss divergence theorem. So according to that we can write this closed surface integral of d bar dot ds bar is equal to the volume integral of the divergence of the flux density vector d bar. So that way we get this equation. Let's call it equation 2. The previous equation is 1. Now we can write this charge enclosed in the closed surface in the volume can be written as q is equal to the volume integral of rho dv. Rho is the charge density. Let's say we know the charge density within this volume. So then the total charge q is nothing but the integral of the charge density all over this volume. So volume integral of rho dv is q. Now therefore we can rewrite the equation 1 using the equation 2 and 3 like this. So therefore we can write this closed surface integral as the volume integral of divergence of d bar dv, and charge q can be written as the volume integral of rho dv. So both sides we have volume integral, that means this integrand is also equal, that means divergence of d bar is equal to rho. So this is the another form of writing the Gauss law of electrostatics. Here we can replace d bar by the actual electric field vector E bar by remembering that d bar is equal to epsilon E bar. Then we get this divergence of E bar is equal to rho by epsilon. So this equation is called as the Gauss law in differential form, whereas the previous equation, the closed surface integral of d bar dot ds bar is equal to q, is called as the Gauss law in integral form.